Hi all. So this is lecture 4 of Calc 2 lectures, and today I'll be discussing the trigonometric integration part 2. So in this sort of integrations, we'll see how to tackle integration involving tangent and secant. So say I have one integration like this, then I can see that I have 10 to the 5x and secant square x dx. So in this case, I just have to use u substitution, because if I take my u to be, let u to be tangent x, then du will be, sorry, secant square x dx. Okay, so if I replace it, then I'll have the integration as u to the 5 du, right? And that is nothing but u to the 6 over 6 plus c. And at the end, I'll replace u by tangent of x. Then I'll have that as my answer. Cool. Similarly, in this other type of integration, you see that I have secant to the 5 and then sec x tangent x. Though, so in this case also I can take my u to be secant x. Then my du will be secant x tangent x dx, right? And therefore this integration will become u to the 5 and then du, right? So similarly, I have it to the 6 over 6 over c, and then I'll replace u with secant x to get my answer. Cool. Okay, so now if I have a general type of integration where tangent and secant can be like any power, only one condition is my n should be bigger or equal to 1. Okay, then I have two possibilities. Either this n is even or this m is odd. So if my n is even, uh, then I'll save secant square x and convert remaining secant into tan. I'll use this identity and substitute u as tangent of x. Similarly, for m, when m is odd, I'll save secant x tan x and convert remaining tan into sec. I'll use this identity and substitute u as secant x. So I'll solve one example to make things clearer. So see, I have tangent to the 5 power x and secant to the 6x dx, right? So yeah, so I can see that my n is 6, right? So secant is having power n. So here, this is secant to the 6, right? So therefore, my n is 6, which is even. So I can use 1. So use 1. 1 says save secant square x. So I'll just write this as secant to the 4, sorry. Secant to the 4x and then secant square x. This is my saving and dx. And then remaining secant should be turned into tangent using this this identity. So I see that I have secant to the 4. So I'll keep tangent to the 5 as it is, and this is secant square. So this thing is secant square x whole square. So therefore I can write 1 plus tangent square x whole square, right? I'm using this identity. And then there is secant square x as it is dx. After that, I have to substitute u with tangent. So now let u is my tangent of x. Therefore, this integration becomes u to the 5. This. So u to the 5, 1 plus u square whole square. And this is like du will be secant square x dx. So just du, right? And this thing in the bracket will be 1 plus 2u square plus u to the 4, and then du integration multiply to the 5. So I have e to the 5 plus 2u to the 7 plus u to the 9 du integration. And after doing integration, I'll have e to the 6 over 6 plus 2e to the 8 over 8 plus e to the 10 over 10 plus c. And then at the very end, I'll replace u with tangent, right? So this will be tangent to the 6 over 6. Okay, I need space. Plus 1 over 4 tangent to the 8x over 8. No, over is done. Okay. Sorry. Plus tangent to the 10x over 10 plus c. Okay, this is the answer. So I've shown you that how to use case 1. And if I consider the same integration, then tangent to the 5x, secant to the 6x, then my m here, comparing this, my m here is 5, right? So that's what I have written. M is 5, which is odd. And see, my strategy 2 says that if m is odd, then this is what I need to do. So I'll now use 2 in the same problem. Use 2 now. What does 2 says? Save secant x, tangent x, and convert remaining tan into sec. Okay, let's do that. I had tangent of 5x secant to the 6x dx. So let's save one tangent x and one secant x. Then I'll have tangent to the 4x secant to the 5x dx, right? Now I need to convert tans into sec using this identity. So this is tangent squares x whole square. So then this will become integration, I guess 1 minus secant square, secant square x minus 1. Secant square x minus 1 whole square, secant to the 5x, secant x, tan x, dx. Now let u is secant x, then du is secant x, tan x, dx, right? And therefore replacing everything, I'll have u square minus 1 whole square and then u to the 5 du, right? Which will be u to the 4 minus 2u square plus 1 times u to the 5 du. And that is u to the 9 minus 2 u to the 7 plus u to the 5 du. Okay, I'm done with the integration. Plus c, actually. And then at the end, I'll substitute u by secant x. So I'll have, oh, no. That's doing right. Integration is not done yet. So this is u to the 10 over 10 minus u to the 8 over 8 plus u to the 6 over 6 plus c. Now I'm doing it right. We have some speed there. Okay, and at the very end, when you substitute u with secant, then secant to the 10x over 10 plus 1 over 4 secant to the 8x plus secant to the 6x over 6 plus c. This is the final answer. Cool. Now you can see that the answers for the same problem is this in the first case and this in the second case. Those are different, but that is not something fishy. So in integration, you can have like different answers. As far as the process is like right, you should get the marks. Okay, both are like correct answers. Okay, now I'll go into the reduction formula, but for that, I need to sell things up. Okay, thanks. Okay, so reduction formula is when my n is not 1, then tangent to the n, the integration of that is same as the right hand side. So you can see that the reduction formula is saying that you can reduce this integration, which is in power of tangent to the n, to an integration where you have tangent to the n minus 2. So you are just reducing the power by like 2. And the same formula goes like for, not same, similar formula goes for secant as well. Okay, cool. So one example of applying a reduction formula to the 10 to the 5 is like shown here. I'll solve this again. Okay. So here my n is 5. So I will just use the reduction formula. So I'm using this. So I'll have 1 over 5 minus 1 is 4. Tangent x to the 5 minus 1, so 4, minus tangent to the n minus 2. So tangent to the third x dx. So this is basically 1 over 4 tangent 4x, same thing, minus, here I'll use reduction formula for n equal to 3. Then this becomes 1 over 3 minus 1, which is 2. Tangent to the 3 minus 1 is 2x minus integration tangent to the 3 minus 2, which is 1x dx. Cool. And then this is nothing but 1 over 4 tangent to the 4x minus half tangent square x plus this will be ln secant x plus c, right? So this is a solution for this problem. Okay. So this was more or less about how to deal with integration involving tan, sec, and maybe combinations of them. And the last problem will be this, which is, okay, just erase this. I'll solve it again. Okay. So if you have like one integration where you have this sine x, sine 5x and sine 4x dx. So recall that in the previous lecture, I have added some trigonometric identities at the end. So you might look at it in note of lecture 3. There I have written some more trigonometric identities. So one of them was what is sine A times sine B. So this is the identity for that. Okay. So I'll use that identity over here. So I have sine 5x, sine 4x. So my A is 5x and my B is 4x. So this will be integration half cosine A minus B. So 5x minus 4x is x minus cosine A plus B. 5x plus 4x is 9x dx. Okay. Now this is, if we do integration, this will be half sine x minus half, say, integration cosine 9x dx. And then you can do this last integration like by hand, or like you can take your substitution u to be 9x, then your du is 9 dx, which is nothing but 1 over 9 du is just dx. Then we just do the u substitution back over here. So half, then cosine u dx is 1 over 9 du, so 1 over 9 du right here, which is half sine x minus, oh sorry, 18, 1 over 18 cosine u du, so which will be half sine x minus 1 over 18 sine u plus c. And at the end, you just replace u with 9x, 1 over 18 sine 9x plus c. Okay. This is your answer. Cool. Yeah, so this is all I intended to say today. So next week I'll be traveling, so please check the announcement. I'll make one probably by the end of tomorrow. So yeah, there might be some um reschedule with the office hours. Okay, cool. Thank you.